Hey there. Fossil fuels, their origins and the energy of the future. In the last video, we already explored some of the prerequisites that I think are necessary for a technologically advanced civilization to develop it all. While we were at it, I also mentioned the energy reserves necessary for the beginning and the further development of technological advancement. As an example, let's take a look at the beginning of the Industrial Revolution, some 300 years ago. Without the fossil fuels, namely natural gas, crude oil, and coal, the Industrial Revolution would not have progressed past the very first steps. Once all the trees and shrubs were burned, industry wouldn't have been able to evolve any further. It would have stopped right there. So the planet had to support the evolution of humankind, and it has done so ever since the beginning of life, starting with the first single-celled organisms. According to my hypothesis, this is how it went down. After the Earth had cooled down and the crust had formed, asteroids and comets kept falling on the young planet. These comets and asteroids also brought, among other things, water with them. The first single-celled organisms developed in the lakes and seas which had formed. More and more, until it wasn't water anymore, but a viscous liquid of single cells. An indication of this could be the viscous form of crude oil today. As a result of further comet impacts, these lakes and seas were covered by large amounts of earth and thus preserved. This is how, according to my hypothesis, the crude oil and natural gas we use today as fossil fuels came about, and if my hypothesis about the formation of crude oil is correct, then there must be crude oil deposits on Mars also. Not in the same amounts as on Earth, but in substantial amounts though. Research should be made to refute or confirm this hypothesis. For comparison, the official version, according to Wikipedia, says petroleum as a fossil fuel derived from ancient fossilized organic materials such as zooplankton and algae. Vast amounts of these remains settled to sea and lake bottoms, where they were covered in stagnant water with no dissolved oxygen, or sediments such as mud and slid faster than they could decompose. If the classical theory about the origin of crude oil were to be correct, then crude oil should be found in all possible stages of development in the bottoms of all oceans and seas. But that's not the case. Let's take a look on coal. Coal has a different creation process since it is almost exclusively plant-based. Trees, shrubs, and other forms of vegetation exist on the mainland only since 350 to 400 million years. Here's what the classical theory says about the origin of coal according to Wikipedia. At various times at the geologic past, the Earth had dense forests in low-lying wetland areas. In these wetlands, the process of coalification began when dead plant matter was protected from biodegradation and oxidation, usually by mud or acidic water, and was converted into peat. This trapped the carbon in peat bogs that were eventually deeply buried by sediments. I have doubts on the classical theory because of the following reasons. If it was valid, you should be able to find in different stages of coal sediments in various places on Earth, like swamps, peat bogs, for example. However, there is nothing comparable to be found in them. So, how did the big amount of dead plants come together to explain the amount of coal we find today? Because it's one thing to gather that much material, and another thing to cover it up before it rots. As a reminder, for 1 meter of coal, you need 6 meters of plant material. I think that the process was similar to that of crude oil. Only asteroids and comets had the necessary force and energy to disroot the vegetation of entire districts and assemble them in large valleys through floodings and finally seal them with soil, sand, and rocks. Research to To verify or disprove this hypothesis should be done by now, since doubts about the classical theory are very much legitimate. Now, just one word on the energy of the future. Since the amount of fossil fuels is limited, humans should research a new source of energy that can satisfy the energy demand of the future, not only in short, but in long term. For example, looking into the future several hundred years from now. What is called today the energy of the future, like wind, solar cells, and hydrogen, cannot satisfy mankind's hunger for energy. Not today, and certainly not in the future. Space travel cannot be done with wind and solar energy. And with hydrogen as a drive, you can at best get to Mars. If you can't do space travel with it, well, then it's not the energy of the future for me. See you next time.